Welcome. In this video, we're going to explore another fascinating way to estimate the value of pi, this time using an infinite series. This method, known as the Leibniz series, is a powerful demonstration of how mathematical formulas can approximate pi using an ongoing sum of numbers. Explanation. Let's break it down. The idea behind using an infinite series is that we can approximate pi by adding and subtracting fractions continuously. In this series, the terms alternate between positive and negative, and they become smaller as we go further. The more terms we include, the closer we get to pi. Although it takes many terms to get an accurate result, this series gives us a straightforward approach to finding pi. Each new term brings the value closer and closer to what we recognize as pi. How it works. Here's how the process works step by step. First, we decide how many terms of the series we want to include in our calculation. The more terms we use, the better the estimate. Starting from the first term, we add the next term, then subtract the one after that, and so on. The pattern is alternating: positive, negative, positive, negative. This pattern is crucial because the series balances itself out as it progresses, refining the estimate with each new term. After calculating the sum of these terms, we multiply the result by 4. This gives us the estimate of pi. Let's dive into the intuition behind how Leibniz derived his famous formula to calculate pi. The formula comes from a branch of mathematics known as calculus, and specifically, something called the Taylor series. We won't use complicated math here, but we'll explain the big ideas that help us understand where this formula comes from. To start, imagine we have a function that describes part of a circle. What Leibniz was trying to do was find a way to approximate this curve using a series of simpler terms. He realized that by breaking down the curve into smaller and smaller straight segments, we could get closer and closer to the shape of the curve. Here's the cool part. Calculus gives us a tool called the Taylor series, which allows us to approximate functions, like curves, using an infinite sum of simpler terms, kind of like stacking pieces of a puzzle to recreate a bigger picture. In the case of pi, Leibniz used this tool to approximate the curve of a circle using fractions that get smaller and smaller. So, how does this connect to pi? Leibniz knew that there's a relationship between circles and a specific mathematical function called the arctangent function. This function has a Taylor series, which means it can be written as an infinite sum of terms. Each term is smaller than the one before it, and the series alternates between positive and negative numbers. By adding and subtracting these terms in the right way, Leibniz figured out that this series could be used to approximate pi. Specifically, the series he found looks like a sequence of fractions. You add one, subtract the next, add the next, and so on. As you keep going, the result gets closer and closer to pi, even though each new term becomes smaller and smaller.